Hi, okay, we're still working on our KSPs. We're going to be working on example 13 to start with. So example 13, let's jump right in. We have calcium fluoride is our insoluble salt. So you have to recognize that since it's ionic, it's a salt. Even if you don't know your fluoride rules for this, look, it gives you a KSP for calcium fluoride. That's the clue that calcium fluoride's only a slightly soluble salt. So let's pop this in here. I'd have calcium fluoride solid in equilibrium with its ions, one calcium ion and two fluoride ions. Now let's go ahead and set up the KSP expression. When you're doing WebAssign, that's going to be a very needed step. On an AP test and on my tests, you'll likely be walked through that. You'll be asked to set it up. You won't have to think to set it up. Remember, nobody's going to give you a rice grid. Nobody's going to give you the letters DSE, which maybe we should say doc saves everyone, so your parents aren't thinking you're being disrespectful for your teacher. I don't really care. But there is no dilution here, right? Okay, I do care if you're disrespectful. I don't care if you use Doc or Dina in your head with your checklist. There is no stoichiometry. We have one salt, and it's a very slightly soluble salt. So we need to move into our equilibrium. Now, the question asks us for KSP. I think the difficulty here is it says the concentration has been found to be 2.4 times 10 to the negative 4. There is an implication in that after as much as dissolved as can possibly dissolve, this is 2.4 times 10 to the minus 4 molar. So that means there's some of this. We've lost an amount equal to its solubility, and as long as we still have some left, we don't care how much. It's irrelevant. We had none of this because there's no other source of calcium ion than our insoluble salt. Won't be true in a minute. None of that. This would be plus S. Excuse me, started thinking ahead to the fluoride here. That's going to be plus S, and the fluoride's going to be plus 2S. So the fluoride is 2 times the solubility. Well, in telling us how much calcium ion dissolved, they're telling us in the problem what S is. Okay, so now we can plug that in. If we know what S is, we certainly know what 2S is. And if we plug those numbers in for KSP, we'd have KSP is equal to 2.4 times 10 to the minus 4th. Now be careful because this is 2S, and that 2 really comes into play twice. It comes into play because of the stoichiometry, but it also comes into play because we have to square that value. So that would give us a KSP of 5 point, let's see, I'm going to go to 2 sig figs because that's what's in the problem, 10 to the minus 11th. Now, technically, it would be molarity times molarity squared or molarity cubed. I'm not going to worry so much about that, but AIB students, you want to keep that in the back of your mind. Now, let's do the next one, 14. This time, we are given the KSP, and we're asked to calculate the solubility. So all we have is an insoluble salt and no soluble salts. All sulfates are soluble except for silver, lead 2, mercury 1, and that calcium, strontium, barium trio. So we have our strontium sulfate, solid, going to strontium ions plus sulfate ions. Now, as long as we have some left indicating that it is fully saturated, we don't care how much. Okay? We have none of this and none of that. We're assuming that all of this comes from whatever ion is freed up. Since this is a 1-to-1 mole ratio, that's plus your solubility, So we've got S times S. So KSP is equal to my concentration of strontium ion times sulfate ion. And that's going to be S times S. Well, we're given KSP. So again, this is a fairly straightforward. I'm going to show you in class probably the hardest AP question I've ever come across, and it is an older solubility question. Not sure if it is something that would be chosen anymore. It's an older one. So 2.4 times 10 to the minus 7th is equal to S squared. If I solve that for S, that means my solubility at whatever temperature we're talking about here is 4.9 times 10 to the minus 4th moles for every liter of solution that we have. And again, remember, this has to be at a given temperature, right? Can't you dissolve more sugar in your tea if the tea is hot than if it's cold? Well, equilibrium and solubility both depend on temperature. Got to be careful with that. All right, now we have 15. What I'm doing right now is just moving into some with some different stoichiometries here. We have cobalt 2-phosphate. Now, always, 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 when you see that it's KSP, put the solid salt as your reactant for the KSP portion. So I get 3 cobalt ions. Whoops, I can't write that very well. I'm going to get 3 cobalt ions and 2 phosphate ions. And we're going to assume those are aqueous, PO4 3 minus. Okay. Now, again, this one's now the concentration of all ions present. So that means I need to find not the solubility alone, but also of each individual ion. So as long as we have some salt present, which is implied in these questions, as long as there's some at the end, right? No other source of cobalt. I could have put, say, cobalt 3 nitrate in. No other source of phosphate. So that's a big fat 0 there. Won't be in just a minute. Be patient on that one. Now this is plus 3 times the solubility because that's a 3-to-1 ratio. And this is plus 2 times the solubility because that's a 2-to-1 ratio. So I have 3S and 2S. KSP is equal to my concentration of cobalt ion. Whoops, that should be a 2, not a 3. I just caught that. Sorry about that. 2 cubed times my phosphate squared. I'm glad I caught that before it confused you in class. All right, we're given KSP. So we have 2.05 times 10 to the minus 35 is equal to, now in place of the cobalt, I'm going to put 3S. So that's 3S cubed. In place of the phosphate, I'm going to put 2S, and then I'm going to square that. And yes, you do have to use, try to find the 5th root. Your calculator will have that. If you can't find it on your calculator, you want to come see me, and I'll show you where that is. It was no big deal. I could even do it on the little scientific calculator on my iPhone, which can be a little touchy, literally. So there's my solubility is 4.5 times 10 to the minus 8th. Now to find my concentration of cobalt ion, all I have to do is take 3 times that S. And I'm not going to do that because I don't have those values right here. I'm not going to spend time with that. I didn't calculate them before I started this, and that's just going to be 2 times whatever that solubility is. So that's how you would finish that problem.